Okay, so first of all, welcome everyone. Thanks a lot for this meetup. It's pretty cool to be able to go in meetups in other countries, so pretty cool. First of all, sorry for the accent. I hope it will not be a problem, but normally it should be okay. And today the talk will not focus so much on TypeScript itself, but we will focus on ways to test our software differently. And today we'll talk about property-based testing, which is another way to test your code. And I hope at the end of this talk, you will be able to use it in your own project. So before we start, let's first of all describe an issue that I think happened to any of us. We've worked hard on a very complex piece of code, or maybe some simple one, and we released it to production. And at the end, we got an issue. We got a bug, and people are complaining because there is a very problematic bugs, or maybe not so problematic. But at the end, there is a bug, and we were not expecting to have this bug. And actually, I think we feel a bit like this little dog. We fell down the stairs. We thought that we reached the end and that the project was okay. And at the end, we got something very problematic, a problematic bug. But first of all, it happens to all kinds of companies, from big companies to small companies, from very famous one to not famous one. And as an example, this is a bug taken from Android. So basically, they had an issue a few years ago that allowed anyone to bypass the lock screen without knowing the password. And the scenario is, I don't know what you think about the scenario, but in my case, I believe that this scenario is pretty complex because it's made of 8 different steps, and all of those steps are pretty complex. And I'm not sure I will be able to cover this kind of scenario with my usual set of tests. But before we move on to see other kind of tests we can do on this kind of problem in order to detect those kind of issues, let's first of all see what we have today in order to detect problems. So most of the time, when people introduce testing strategies, they come with the testing pyramid, and in some cases, the testing trophy. But in any way, it's the same. We have unit test, integration test, and end-to-end test, which are basically different layers of test that make us confident enough in our software when we release it. A typical unit test, so this one is written using Jest. I think it was in TypeScript. So yes, TypeScript. Basically, I'm testing an algorithm which is called Knus-Moritz-Prat. So it basically takes 2 strings. Let's call them A and B. And it will check if the second string is a substring of the first one. And in case it's a substring of the first one, it will give us the index where the second string starts. So we just, for instance, this is an example of how we can cover this kind of algorithm. So we basically write a first test, empty string, and we expect to have the result 0, and so on and so forth. So we write several of those tests. And when we are confident enough that we covered all the edge cases, we are okay and we can release our function to someone else. If you have a look to this specific code snippet, you can see that, first of all, what we do in this kind of test is basically we are hard-coding some kind of entries, and given those possible inputs, we check that the output is the one we were expecting. So basically, we said that given string empty and string empty, we were expecting to see 0, and this is some kind of hard-coded stuff. Let's see how we do for end-to-end test. So basically, this one is the example from the official documentation of Selenium. And Selenium can be used to do web testing. And in this test, I'm basically opening a web page on google.com, trying to type some stuff in the search field. And at the end, I'm expecting to be redirected to a web page where the title is WebDriver Google Search. We have exactly the same way to write this kind of test as the one we've seen before. We have an hard-coded input, which is in this case the scenario, and an hard-coded output. In this case, this is the fact that we will find a search field where we will type our text. And we also, this is also the title we are expecting to see. Basically, this is an output we are expecting to see. So given some hard-coded inputs, we expect to see some outputs. But the question we may ask ourselves when we write tests in general is, are we sure to cover everything? Or at least, are we sure to cover everything that can go wrong for our users? Most of the time, people will say, okay, I have users and users are okay with my code. They seem to be happy with the code. And there is no bug so far. And I'd say it's the case of Android. And it was the case of Android when they had the bug, but they had an issue. So it's not enough. And another thing that most of people will say is, okay, I have 100% coverage, so everything should be okay. And for this one, I will just say that even with 100% coverage, you are not sure to cover everything properly. At least you are not sure to cover everything properly. So it's not enough. But before we move on, let me first introduce myself. So my name is Nicolas, Nicolas DUBIEN. I'm working for a startup company which has been started a year ago, which is called Pigment. And today you can find me on GitHub Dubs and Twitter and DUBIEN. And this is the project I will introduce you later on, which is called FastCheck. So we'll have time to talk about this project a bit later on. So let's move on to the topic of today, property-based testing and ways to detect bugs a bit earlier. And I think the first thing we need to ask ourselves when we have those kind of issues and knowing what we have today in order to detect those issues is, what do we miss and how can we do to detect problems a bit earlier in the development lifecycle? And basically, I would say that today, the problem we have is that we are testing a very limited scope of inputs. If we think about the case of Knus-Morris-Pratt, the algorithm that is checking if a string is a substring of another one, basically, we were testing this code using only 10 possible couples of inputs. But the set of possible inputs, the total set of all the inputs we can put into this algorithm is infinite. So we were covering an infinite set of inputs with just a very small set of possible inputs. So we may have missed some edge cases. And this is the aim of the technique I will show you, is basically to find a way to cover those edge cases in a clever way. So basically what I will introduce you today is we will go for random. Why do we want to go for random? We want to go for random in order to test more stuff, because today if we hardcode stuff, we will still have the same issue. We will only test a very, very restricted set of inputs. And we want to cover more. We want to be able to make sure that our code will work, whatever the inputs we put into the algorithm. But we want to do it in a clever way. So basically, what is important today is that we want to have a reproducible way to do randomness. And basically what the classical solution to do that is basically to use seeds. So our solution will be to rely on seeds. And another point which is important is that I don't want to be deterministic. What I mean by deterministic in this case is that each time I will run my test suite, I want to test new things. Because each time I run a new test, I want to test other kind of possible inputs so that at the end, after an infinite amount of time, I will be able to cover all the set of possible inputs. But in case of failure, I'm still able to reproduce the issue because I have a seed. But there is still an issue because random is okay. We can replay it. We can maybe report errors. We can do some stuff around it, but there is still an issue. We are talking about random, and random will generate very strange inputs. For instance, we can imagine that we have an error with inputs like those ones. In that case, I think we can still take a bit of time in order to think about it and find where is the issue. But actually, we can have even worse input. We can have bugs with very long strings of characters. And I think in those cases, I don't know you, but in my case, I will maybe it will be a bit problematic to debug stuff where strings having thousands of characters. So maybe I want to have something more clever. I want to have better errors. So before we move on, let's just talk about property-based testing. I don't know if you've heard about property-based testing, and it will be difficult to know that with Zoom. Either you know it or either you don't know it. That's not really an issue. The idea of this talk is just to cover what is property-based testing and give you ways to use it in your personal project if you want to. So basically today I will introduce you property-based testing by using a library which is called FastCheck. It's written in TypeScript and it can be used with TypeScript or with JavaScript if you want to. I'm basically the author of the framework, but which is important to know is that this project has already been used by big other projects such as Jest or Jasmine today. But let's go on and let's move to what is property-based testing. So basically, property-based testing will test properties instead of isolated cases. In our previous set of examples, what we were doing is just covering very hard-coded examples. And for those hard-coded examples, we were thinking about possible outputs. In the case of property-based testing, what we want to do is to test properties. So basically, properties can be expressed as follows. For all x and y, such as x and y are okay with a certain precondition, I want to check a property. In terms of how it will be understandable by the framework, it's basically, the framework will understand the first statement as generate random inputs based on the specified generators. So in this example, x and y, given the generated values, I want to check that those generated values are okay given some preconditions. If they are not, I need to regenerate new entries. So basically, I will generate new entries until I reach a real and okay, a good input, a good set of inputs. Basically, you can think about something like I want x to be smaller than y, for instance. And until I don't have this kind of precondition, okay, I will generate again and again new values. Most of the time, we don't use so much precondition in property-based. Ideally, generators should be good enough to do what we want. And at the end, we run the properties. So basically, we take x and y, and we check that we give a property is working fine with x and y. And in case of failure, we will just run what is called stringing, but we will go into more details of this stuff later on. And we will run this stuff 100 times. Most of property-based testing framework, even in other programming languages, will run tests 100 times. But let's illustrate that with a very simple example. We will consider an example based on is substring. So basically, a substring is an algorithm that takes two strings and will check if a string is a substring of another one. For is substring, I want to define a property. So basically, I want to define for all x and y, such as a precondition odds, I have a property which is okay. A possible property we can write for is substring is the following one. So for all a, b, and c strings, I want to check that b is a substring of a plus b plus c. And basically, it's more visual, so we can see that visually. So basically, if we take a, b, c as follow, we see that b is a substring of a plus b plus c. But what if we have an issue? To remind you that we still have an issue that we've not covered so far. Basically, what do we do if we have an issue with very strange inputs? And this is what I will cover just there is what the framework will do for you, but we will try to do it on our own before. So we will try to do shrinking. So shrinking is basically taking a failure, and given a failure, it will try to give you a smaller failure. So basically, a possible way to reduce the failure will be to remove the string a. So given we removed the string a and replaced it by an empty string, we still have the failure because there is a red cross. Then we do the same for b, but we do not have anymore the failure. So it means that with b empty and a empty and c having the value we see there, we don't have the bug. So we'll try to add back some laters and so on and so forth until we get the minimal possible failure. In our case, this is the minimal possible failure. And what is important is that property-based testing framework will most of the time do that for you. So you don't have to do that manually, they will do that for you. So in order to test it and in order to see how we can do that, I think the best way will be just to check it with a real example. So let's try property-based testing, and we'll use the algorithm we talked about at the beginning of this talk, which is called Knus-Morris-Pratt. And this algorithm can be used to write is substring. So it's basically, we just use Knut in order to define is substring. So we want to test is substring. So in order to test is substring, we'll use a property we defined together at the beginning, a few times ago in the talk. So for all ABC strings, I want to check that B is a substring of A plus B plus C. So let's see that. I don't know if you see my VS Code. I think it should be okay. And so in this VS Code, I've imported the algorithm of Knut there. I have some kind of unit test. I can run the unit test again just to make sure if they are passing. And now let's see together how we can write this property. So just to have it on the screen for all ABC strings, I want to check that B substring of A plus B plus C. So this is what I want to check using fastcheck. So I've already imported fastcheck with FC at the beginning of the file there. So I will just, as any test, give a name for my test. So this one, I don't have IDs for the name, so I'm just using a fake name property. Then I will define a property. So basically, I'm using fc.property, which is able to give me a property. This property is using three inputs, which are strings. So I asked fastcheck to generate strings. So fc.string will be a generator of string, which is already built in the framework. And given I have my strings, I can write the property. So basically, I have three random generators. They are my X and Y. And there, now that I have my generators, I can get back the generated values. And you can see we have three strings, A, B, and C. And there I will want to check my property. So in my case, the property is I'm expected the output of Knus to confirm what I was saying before, that B is a substring of A plus B plus C. In the case of this algorithm, it's identical to say Knus different from -1. So this is what we want to write. And the last thing we need to do in order to ask the framework to run the property is to use the test runner for fastcheck, which is called assert. And we'll use fc assert. And now we have our property. We can run the property on this algorithm and check if there is a bug. Basically, okay, so I have a bug. So you can see that the property failed after seven tests. It failed with a given seed. So I can use this seed in order to replace the problem. And when it failed, the reduced cases, so the case after shrink was empty string, empty string, empty string. And what the framework told me is that it has to shrink 2 times in order to get to this small example. So we can just, if we want to replay the scenario, we just have to add the case directly there, and we will be able to replay exactly the same issue. We can basically redo the test multiple times if we want to. But let's move on to the next part. So basically, we've written our first property. So this is the property we just came up with. For your information, of the implementation of Knus we were using is the implementation that has been provided by JavaScript algorithm, which is a GitHub repository that reached like 50K stars a year ago, if I'm not wrong. And it provides a lot of algorithms. And among those algorithms, there were some kind of Knut algorithm, and they had some bug. And they have the bug we've seen together. They also had another problem, and this problem was with RabbinCarp, which is exactly the same algorithm as Knus in terms of usage. It does the same. So it's pretty useful to run those properties, because sometimes, even if we have lots of people looking to the code, we can still have bugs. And I think those 2 examples are proof that we can find bugs in very used libraries. But in the case of the property we've just talked about, I think we have still an issue. We only covered one specific corner case of the algorithm. We were covering only truthy cases. What I mean is that what we are covering in this test is that we expect the output of Knus to be different from -1 every time. So basically, if I implement Knus to be a function that always returns 0, it will pass the property. And I think this is something which is pretty important when you do property-based testing. Not everything can be covered using property-based testing. It's just an additional layer of test that can help you to detect other issues, but it doesn't replace examples you are used to write in your code. But for this precise example, I think we can go a bit further. If we take two random strings, invité and vite, which are two French words, we can see that vite is a substring of the first string, so B is a substring of A. And if we run knus on those two strings, it will give us 2. What it means is that if I take a substring of A starting at position 2 and of length V, I will have B. So basically, this is another property I can get out of this code. So basically, my property will be, I want to generate 2 random strings, and I will run the algorithm of knus over those strings. I take back the index, and given this index, it's either -1 or the position of the match. And this is another property we can come up with. And it can be written using FastCheck with something simple like this stuff. But I think the most important stuff is, okay, this library, this GitHub repository was pretty impressive. It has lots of stars, but it's not, I think it's not a library you are using in your code base because they do not have real library behind the scene. What if we use property-based testing on real libraries? What if we use property-based testing to test _JS, which is, I'd say, a library for JavaScript and TypeScript, and we'll use underscore and make sure that is_equal is working properly. And is_equal has a very important property, which is is_equal is supposed to be symmetric. What does I mean by symmetric is that, what do I mean by symmetric? I mean that for any A and B values, I expect is_equal of A and B to be the same as is_equal of B and A. Maybe we can just write this test together. So basically, what I will do is just import. I will import my my library underscore. I'm just going to remove all the codes there. And there I will start with an empty property. Let's say I have an empty property. In my case, what I want is to generate anything. So I ask the framework to generate anything for me. So basically I ask anything and anything. Given those anythings, I have A and B, which are anything. And if I'm checking the types, they are unknown and unknown. So it seems pretty cool. What I want to check is basically that is_equal of, is_equal AG equal is_equal BA. So this is what I want to check. Another thing I just want to add is that I want to have more values. So what I want to do is basically I want to enable box values, for instance. I want to have sets which are not the default. So I can enable set, I can enable box values, and the same for the other one. It's just to generate even more values, for instance. I don't know if I have something wrong. And I will run the property. If everything is okay. Sorry, I just have something wrong. I think I don't know what I ran to. Just, oh, sorry. It's just the import that was failing. Okay, so let's take back this stuff. I run the property. Normally everything should be okay because I'm testing against underscore. So underscore has been used by lots of companies, so it's passing. One thing which is pretty important is that with FastCheck, you can change the number of runs you are playing. So basically, what if we ask for 1,000 tests, more tests? So let's say we run 100,000 tests. So we run the same more tests on the same code, and we just want to make sure that the code is still passing given this amount of tests. So it takes a bit longer because it might have to run really a lot of tests in order to find a bug. If there is a bug, if there is no bug, there is no big issue. And I think so. One of the tests failed, but my automatic test runner found a bug for number, not a number, and new number of not a number. I think this stuff is pretty important. It's that property-based testing might be green, and if you run it after, it might be red. what is important in that stuff is that whenever you do property-based testing, you need to be sure, you need to keep in mind that maybe your test will be green and later on might be red because you have a real bug in your test. And I think it's important to know that if it's coming red, it means that you have a bug. So basically, this is the property we come up with. As we've seen together, we found an issue with underscore. And the issue I found with underscore is exactly an issue that I was able to reproduce on Jest. So the same bug we have the same bug in Jest. Jasmine has also the same bug. And we also had another issue in Jest that we can find with this symmetric property. And that's all for the bugs. So and for the live coding session. But we can go, I think we can go a bit further with property-based testing. Most of the time, people use property-based testing to show very simple example like I showed you before. So basically, example with very simple property and with libraries. But I think it's important to keep in mind that property-based can be used for even complex example, even for complex example. So this is a test I run as an end-to-end test using property-based testing. In my case, I was playing with a Connect 4 game, and basically the property-based test was just clicking on buttons everywhere in order to check if all my properties were okay on an end-to-end test. And I think that's pretty all for the talk. One thing which is, I think, important to keep in mind is that property-based is just another layer of test. It can help you to detect bugs you've never thought about. And it may be green one day and red another day. Most of the time, it will be red the first time when you have real bugs. I think that's all for the talk on my side.